Assistant Professor, Department of ISE. So I would like to explain the concept of the sum of subset, which is nothing but a program number 11 and a subject code 15 CSL47. Okay, sum of subset is based on the backtracking technique. So let's see the working of the program.
Good morning, students. Welcome to the 11th program, that is sum of subset. Okay, it is based on the backtracking. Okay, it is based on the backtracking method. So here, as usual, it is import java.util.scanner or .star. Okay, so here we are going to create a public class sum of subset where the maximum number of elements, the number of elements. Okay, so the source, solution, and D. So what is this D? The D is nothing but the value which you are going to enter. So using this backtracking, okay, so we are going to find out the sum of subset. Given a n number of subsets or given a n number of elements, you are going to find out, suppose the D value is 9, the given is 2, 3, 4, 5 and 6. So what makes 9? It is 3 and 9. Okay, 3 and 9 and 2, 3 and 4. So these are the possible answers. Okay, so next again public static void main string arguments. Okay, s equals, you're going to enter and solution matrix, then again and the sum equals 0. Next again here we have a scanner. Next enter the number of elements into the set in increasing order. We're using a scanner and using the for loop. We are going to enter it into s of I. Next we are going to enter the maximum subset value, that is the D. Okay, and based on that particular value, I equals 1, I less than or equal to I plus plus. So what we are going to do, sum equals sum plus s of I. Okay, sum equals sum plus s of I. So we go on adding the elements here to the sum. We go on adding the element. So if the sum is less than D, that is the D value is 9 which we are given, and then the value of that s of 1 is greater than D, then no subset is possible. Else, if there are just 1 or 2 elements. Okay, this is for 1 or 2 elements. Next, else you are going to call this sum of subset. Okay, so the arguments are 0, 0 and sum. Okay, so static sum of subset int I, weight and total. If promising I, weight and total equals true. Yes, what is that promising? If weight plus total is greater or equal to D, yes. And if weight is equal to D, what is D? D is 9 in our case. Or if the weight plus the element which you are going to consider, if it is less than or equal to D, then only that particular entry will be promising. If that is true, weight equals D. If the weight is equals D, then what you're going to do, you're going to find out the solution. Yes, a solution has been found out. Else, what you're going to do, you're going to consider the next element. Yes, I'm going to consider next element. Next sum of subset, I'm going to consider the next element, comma, the weight. To the weight, I'm going to add the s of I plus 1 weight, and from the total, I'm going to minus that particular. From the total weight, I'm going to minus that particular value of s of I plus 1. Next, solution of I plus 1 equals 0, and again I'm going to call the sum of subset for the next elements, that is for I plus 1, weight and total minus s of I plus 1. Again it comes here and again is going to find out the values. Okay, until and unless the condition fails, until and unless the weight is equal to D. Okay, now let's see the input. So the input here will be enter the number of elements 5. So you're going to enter in increasing order 2, 3, 4, 5 and 6. Enter the maximum subset value 9. So what makes that? 2, 3 and 4, 5 and 4, 3 and 6. Okay, so these are the input. Okay, these are the for the input which you are given. These are the output. Thank you.